Hi, this is Dr. S and this is video 15 of my series on aromatic chemistry for OCR A-level. In this video we're looking at directing groups. Now in video 14 we looked at activating and deactivating groups, and just to remind us about what that meant, activating groups are groups that are substituted onto a benzene that make the benzene more reactive. So they would be the OH group and the NH2 group, both of which we need to know for the OCR A-level, and then OR and R, and there are some more, but these are the most common ones. On the other side we had the deactivating groups. These are ones that when attached to a benzene actually make the benzene less reactive. So there'd be NO2, which is the one that we need to know for the A-level, and then maybe a carboxylic acid or a nitrile or an aldehyde group. Now what we're going to do is look at the link between whereabouts these then direct the next substitution to. So to give you an idea, we have looked at one already without really knowing it. So when we looked at the reaction of phenol with bromine, we said that it makes a particular product, and that product is 2,4,6 tribromophenol. And what we'll be able to see is that there is no substitution on this position or that position. So it goes on the 2, the 4 and the 6, but not on the 3 or the 5. Now this is actually a reaction you've not seen before. If we had nitrobenzene and tried to react bromine with it, now the first thing is that nitro is a deactivating group. So where with phenol it's activating and we could just use bromine, here we wouldn't be able to use just bromine. We'd have to use bromine with a halogen carrier. So something like Fe, Br3, and some quite harsh conditions. And what that would then make is you'd have your nitro group on the top, but then the bromine would go onto the 3 position. So you can see it's a different position to where the phenol goes. There is a link between whether it's an activating group and the position it directs the next substitution to, or whether it's a deactivating group and the position the next substitution goes to. So let's remind ourselves of the activation and deactivating groups. As we saw with the phenol, this then directs to either the 2 or the 4 position. So we say it is a 2,4 directing group. Now remember what we mean by directing. It's where the next substitution would go if this is already on the benzene. These ones are 3 directing. So the next substitution, if you have one of these on a benzene, would go on the 3 position. Now depending on where you're looking, if you're looking at some more advanced textbooks, or you're looking beyond the spec, or maybe on other exam boards, you might see words like ortho, para and meta. They are quite commonly used names for each position, ortho being 2, para being 4 and meta being 3. But in the OCR A-level you'll see 2,4 directing and 3 directing. So let's have a look at an example of how this would then bear out. I'm going to use the NH2 as my example here. So let's say I had aminobenzene, which is an NH2 on a benzene like that. And let's say we're reacting it in a Friedel-Crafts reaction. So let's say with chloromethane. Okay, you would need a halogen carrier to produce your reactive carbocation in this case. But whereabouts would the methyl group go? Well, if NH2 is an activating group, it's therefore a 2,4 director. So the substitution would either go on 2 or 4. Now depending on whether it's talking about mono substitution or di substitution or tri substitution, it might make a mixture of products. Let's presume it's only mono substitution at this point. Then you would make a mixture of products. You'd have 4 methyl aminobenzene and you'd have 2 methylaminobenzene. If you had an excess of chloromethane and halogen carrier, then you might be able to go all the way to the tri-substituted product, which would be that. Getting the 2 and the 4 position. Now if you are putting 3 on, it's 2, 4 and 6, because the 6 is effectively a 2 position the other way around. Okay, so I can hope you see the link between the previous reactions we've looked at. Let's look at an example of a 3-director. So let's say we have benzoic acid, which has a COH. Remember, this isn't one of the groups that you need for the A level. It's just an extra one, but it is a deactivator. Let's say I was trying to react that with bromine. Again, because it's a deactivator, I would need my halogen carrier. And because it's a deactivator, it directs to the 3 position. So my bromine would go here. Okay. Now, so let's go back to the list of activators and deactivators. Now, what you might see, if you do some further reading, you might find there's one awkward group, which is not in the A level, but I'll tell you about it anyway because it's quite interesting. The halogens, if you've got halogen on a benzene, that's actually slightly deactivating, but it's a 2,4 director. So you won't see that in the A level because it's too complicated. If you do see it, they will have to tell you that it's a 2,4 director. Okay. Right, in the next video, we'll look at trying to use what we've just learnt as part of a synthetic strategy to make a particular molecule. Okay, so I'll see you then.